Hello, mates. About 100 million years ago, Earth was a completely different place, wasn't it? No humans around, just some proper terrifying creatures ruling the roost. Dinosaurs, that's right. These dinosaurs were so massive, they towered over buildings. Jaws so powerful, they could crush your bones in a tick. And they were quick as well, running at something like 90 kilometers an hour. That's about 55 miles per hour for you lot in the States. Truly fearsome beasts they were. They reigned over Earth for more than 170 million years. But then one day, something bonkers happened that wiped them clean off the planet. What exactly went down? And how? Come along, let's dive into it in today's video. As it gets closer to the planet, Earth's gravitational pull gets a bit stronger. They can't see what's coming their way now, can they? The word dinosaur comes from Greek, from the words dinos and sauros. Dinos means terrible, and sauros means lizard. A terrible lizard, that's the literal meaning of dinosaur. The term popped up for the first time in 1841, when a dinosaur fossil was dug up. A British scientist, Richard Owen, coined it. Back then, people didn't know much about dinosaurs or what they looked like, so the early sketches were a bit off. Nothing like what we know today. Take Megalosaurus, one of the first fossils found. Have a gander at the original drawings of it. Years later, as boffins uncovered more clues, the drawings got a proper tweak to look more spot on. That's what they reckon it looks like now. Today, paleontologists worldwide have unearthed over 10,000 dinosaur fossils, and they've identified more than 900 distinct species. You might be chuffed at the idea of finding more fossils, right? Here's a fun fact. Between 2003 and 2022, they've clocked an average of 45 new dinosaur species every year. The paleontologists aren't done yet. Not by a long shot. Have a butcher's at the pics of some new species found last year. One of the oddest is this bizarre dinosaur from Chile, sporting a blade-like weapon on its tail and a beak for a gob. They named it Stegosaurus elengassen. All in all, we know heaps about dinosaurs today, but let's rewind the tape and start this yarn from the beginning, millions of years back. Scientists reckon the first dinosaurs popped up around 230 to 240 million years ago. The oldest fossils we've got are from 231.4 million years ago, dug up in Africa. Back then, Earth was a totally different kettle of fish. The continents you know now, Asia, Africa, Australia, Europe, they were all smushed together into one massive supercontinent called Pangaea. Scientists figure Pangaea looked a bit like this. You can even spot where the modern continents fit in. The climate then was dry and arid, with barely a drop of rain. This era is called the Triassic period, the time when dinosaurs started showing up. They were slowly filling the Earth, thanks to evolution. But the dinosaurs of that time, not the massive ones you're picturing. They were pretty titchy, usually just about 2 meters long, that's roughly 6.5 feet. Take Eoraptor, for instance, a dinosaur from that period. It's pegged as the ancestor of other dinosaurs. The big shots of that era were giant reptiles. Some of them were quite cute, like this little fella thought to be the granddaddy of all turtles. Over time, Earth started shifting. Around 201 million years ago, the Triassic period wrapped up when the climate went haywire all of a sudden. Pangaea began splitting apart. Now, when I say sudden, it wasn't overnight. It was gradual over thousands of years. But in geological terms, that's quick. Cracks formed in the supercontinent, and massive volcanic eruptions kicked off around them. All that lava spewed out heaps of carbon dioxide and sulfur dioxide into the air, sparking intense global warming. The sulfur and aerosols blocked sunlight, cooling things down a bit, and the oceans turned acidic as the gases mixed with water. The climate was flipping fast, and survival got tough for the critters around then. Most of those reptiles and other species were cold-blooded. They couldn't hack the temperature swings. But dinosaurs, They were warm-blooded, like us humans, so they could handle it better. The eruptions and climate chaos raged on for about 600,000 years, wiping out nearly all other species. The only ones left standing were dinosaurs, crocodiles, turtles, and some early mammals. This whole mess is called the Triassic-Jurassic extinction event. After that, the Triassic period was done, and the Jurassic period kicked off. Sound familiar? Yep, that's where Jurassic Park got its name. The Jurassic period ran from 201 million to 145 million years ago. Dinosaurs took over as the top dogs on the planet. Evolution made some of them absolutely massive, like the early Titanosaurus, living around 160 million years ago. These beasts weighed up to 15,000 kilograms, that's over 33,000 pounds, and stretched up to 15 meters, or about 50 feet. Other iconic dinosaurs popped up too. Some even evolved to fly, like Archaeopteryx, one of the first feathered dinosaurs. By then, Pangaea had split into two smaller supercontinents, Laurasia and Gondwanaland. Now, thanks to Jurassic Park, the Jurassic period's pretty famous, but it was the next era, the Cretaceous period, when dinosaurs really hit their stride. This is when we saw a proper explosion of dinosaur diversity. Loads of new species evolved, including the T-Rex, the film star of Dinosaurs. It only reached peak power at the end of the Cretaceous, around 65 to 68 million years ago. Fun fact: most scientists say T-Rex didn't even exist in the Jurassic period, so it's a bit ironic it's the face of Jurassic Park. The Cretaceous period was the longest stretch of the dinosaur era, from 145 million to 65 million years ago. The two supercontinents kept breaking up, and the layout started looking more like the continents we know today. Flowering plants popped up, the Earth was warmer, and sea levels were high. Every kind of dinosaur you can imagine roamed around. Raptors, armored dinosaurs, giant plant eaters, and deadly meat eaters. Titanosaurus, one of the biggest land animals ever, and Argentinosaurus, tipping the scales at 77 tons. That's about 85 US tons. Then there's T-Rex, up to 40 feet long, with jaws stronger than any other animal ever. Here's a quirky bit. Grass didn't evolve until about 70 million years ago. So don't picture a grassy Earth in this story, just other plants. T-Rex and Triceratops showed up around 68 million years ago. Get this, we're closer in time to T-Rex than T-Rex was to the Jurassic period. There's an 80 million year gap between Jurassic and T-Rex, but only 68 million years between us and them. Another cool one from back then was the ornithomimids, ostrich lookalikes that could sprint at 80 kilometers an hour, or about 50 miles per hour. And for flying, Quetzalcoatlus, the biggest flying dinosaur, had a wingspan of 10 to 11 meters, 33 to 36 feet. This was the golden age for dinosaurs. Climate was perfect, new species were popping up, and they had no competition. They were proper kings of Earth. Until one day, bam, something smashed them all to bits. A massive asteroid, 10 to 15 kilometers wide, that's 6 to 9 miles, came hurtling toward Earth and crashed into it 66 million years ago. That impact ended the Cretaceous period. It was zooming at 30 kilometers a second, 18 miles a second, 150 times faster than a jet plane. It slammed into the Yucatan Peninsula in Mexico, right where the Mayan civilization would pop up millions of years later. When it hit, it carved out a crater 180 kilometers wide, about 112 miles. The impact unleashed energy equivalent to 100 teratons of TNT, that's 100 trillion tons. Compare that to the Hiroshima and Nagasaki bombs. This was a billion times more powerful. Everything nearby vaporized in a flash. Soil got flung into the air, the ground heated up, and scorching dust rained down everywhere. Global temperatures spiked for hours, cooking animals thousands of kilometers away alive. Only tiny critters survived the initial blast by hiding underground, underwater, or in caves and tree trunks. But that was just the start. Shockwaves, heat blasts, wildfires, and massive tsunamis followed. Waves possibly 2 kilometers high. That's over a mile. Volcanoes erupted again. Acid rain fell, and earthquakes shook the planet. The short-term effects were brutal, but the long-term ones were worse. Dust blocked sunlight for a year, plunging Earth into a nuclear winter. Temperatures plummeted for 3 years, killing off plants. No sunlight meant no photosynthesis, so plants died, herbivores starved, and carnivores followed. It was a domino effect. Only small omnivores, like mammals, lizards, turtles, and some birds, survived by scavenging dead dinosaurs and plants. The asteroid also smashed carbonate rocks, releasing carbon and sulfur into the air, dimming sunlight for thousands of years and triggering more acid rain. After the nuclear winter, the dust settled, but all that carbon dioxide caused intense global warming. One asteroid rewrote Earth's history for millennia. Barring a few exceptions, no four-legged creature over 25 kilograms, about 55 pounds, made it through. All land dinosaurs were gone, along with over 75% of Earth's species. That's when the Cretaceous period ended and the Paleogene period began. But it wasn't game over. The asteroid gave other species a shot. With dinosaurs out of the picture, mammals stepped up. Horses, whales, bats, and primates evolved in this period, along with snakes and smaller lizards. The only dinosaurs to survive were the flying ones, which evolved into the birds we see today. Yep, birds are basically mini dinosaurs. Chickens and ostriches are the closest living kin to T-Rex. How do we know where this asteroid hit and when? It's down to a rare mineral called iridium. It's scarce on Earth, but common in asteroids. Scientists found a layer of iridium worldwide, dated to 66 million years ago via carbon dating. The craters in the Yucatan Peninsula, half underwater, half on land. You can still see its echoes in the cenotes, these stunning sinkholes forming a ring around it. They're tourist spots now, fancy a swim? So what if an asteroid like that hit today? Would humans go extinct? It's a real risk. NASA tracks over 28,000 near-Earth asteroids, including 800 over a kilometer wide, half a mile or more. But don't panic. Science can predict their paths and even stop them. NASA's DART mission in 2022 proved it by crashing a spacecraft into an asteroid and nudging its trajectory. It's not foolproof, but it's progress. Here's the kicker. The real threat now isn't asteroids, it's us. The dinosaur-killing strike was the 5th mass extinction. Scientists say the 6th is underway, caused by humans, the Holocene extinction. Over the last couple of centuries, we've trashed biodiversity at a mad rate. Deforestation, pollution. It's wiping out species 100 to 1,000 times faster than normal. Thousands of animals are endangered or gone because of us. The UN's tried setting targets, like protecting 30% of land and oceans by 2030, but we're lagging. If we don't sort it, we might not survive either. Humans have only been around 300,000 years compared to dinosaurs 174 million, 600 times longer than us. Can we beat their record, or will we fizzle out before hitting 1 million? Drop your thoughts below. It's up to us to save this planet. Cheers, and I'll catch you in the next one.